Dear participants, am I audible? Dear participants, am I audible? Very good afternoon. This is Malayapan from Pantech eLearning Private Limited, and today we are going to discuss about EV charger and its market strength in India, and how we can design EV charger, and what are all the technology involved on that EV charger. So these things we will discuss in detail. Try to engage with the entire session. So before getting into the topic, I would like to introduce about the Pantech. Pantech is basically educational equipments manufacturing company. From Pantech, you can get lab equipments for. Dear participants, just give me a second. Let me check. Thank you. Thanks for your patience. And so about the Pantech, Pantech is educational equipments manufacturing company. So from Pantech, you can get lab equipments for EV charger, power electronics, and electric vehicle. All these things you can get it as a teaching equipments, and also you will get a latest technology transfer in the name of technical training. So we assure that we will help you to create a 10 projects within a year. So that kind of programs also we are running parallelly. Yes. Right. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 10 million students. And on this vision, we are running many kind of latest webinars on latest technologies. So if you are interested, you can get involved and get engaged so that you can acquire the technology in easy way. Right. And so shall we start the session? So now we are going to discuss about EV charger, right? So can you just share your what doubts on this chat box? What are all the doubts you have about the chat box, about the EV charger? Can you just comment on the comment box? I am just watching your comment. Yes. So can you just comment? What is your doubt on the EV charger? If you have any doubt, just comment in the comment box so that I can understand your requirements. And anybody working in the EV charger? Anybody working in the EV charger? I'm just waiting for your comment. Dear participants, can you just comment in the comment box? See, according to the Indian EV market status, So these are all the major players in India. So those who are all working with the EV. So these players like Toyota, Mahindra, Tata, and Ford, Volkswagen, Daimler. So these are all the guys are producing EV electric vehicle rapidly. So the Indian market is huge, and around the globe, India is the biggest market for EV ecosystem, right? So here at the same time, whatever we selected the topic as EV charger, so in the EV manufacturing and EV charger, the both the domain you have a plenty of opportunity, because in the entire transportation industry we have fulfilled only 5% with the EV. So rest of the 90% are still it is in the IC engine based vehicles, right? So now the point is that you have a 95 percentage space to get a excellent career opportunity in the EV domain. See here, day by day, we can easily check that the Indian market keep on increasing rapidly. So here, the market predicts that 600 billion USD in the year in the year of 20 in the year of 2030. But now we have only 50 billion is the market size as of now in the entire EV market, right, in India. So here now we know that the growth is going to increase rapidly. So what we have to do? So we have to upskill our skill set to match the India market demands. See here, the EV charger so far the what are the so far we have a we again we established the charging station on across the India on various states. See here, again, the Maharashtra has a 660, and Karnataka has 700, and nearly that Madhya Pradesh has a 102, about 200. Rajasthan also have about 200. Delhi nearby that 550, and Tamil Nadu also have some 450, something like that, right? But so far we have installed only 1 to 2 percentage EV charger only we have established. So remaining 98 percentage is going to establish across the India, right? So here, even though if the Karnataka has less charger, but the vehicle EV vehicle is more than the other states, right? So this two graphs clearly shows that keep on that the EV market keep on expanding on day by day basis. So what we have to do at this moment? What we have to do at this moment? Right. So at this moment, we have to target the EV industry to adopt ourselves as much as that the market demands. Right? Yes. So again, let me go through your chat. Charging infrastructure. Yes. How much energy is charging in the load time without any damages? See here, the how much energy charging, it's not like that. Actually, see, if you take a two-wheeler, so the charger capacity is about 1 kilowatt maximum or 2.2 kilowatt maximum. So if you put 2.2 kilowatt for the two-wheeler, you can charge your vehicle minimum 20, within 20%, you can get 80% of the charge. All right. So as of now, the charger, what we are spending 2 rupees per kilometer in the EV market in the EV. Similar way, if you compare the IC engines, you have to spend a minimum 16 rupees per kilometer. If you want to cover with the IC engine, you have to spend 16 kilometers, 16 rupees. Whereas in the EV, you are spending 2 rupees maximum. Because it's a maximum rate is a 2 rupees. But there is a one more point. we cannot assure the same scenario will remain continue for next 5 year or 10 year or 20 years. As of now, we are paying EB charge around per unit charge is about 5 to 6 rupees. But we cannot assure the similar scenario will happen. Yes. So one more point. How does the EV charge, how fast charger works? So minimum 20 minutes required to charge the vehicle up to 40%, up to 80%. Right. So now let's move to the one more topic, interesting topic, that the importance of EV charging industry. See here, if you have I mean, charging infra, then only you will get a proper ecosystem. So see here, if is the user going to if the user decided to purchase a new vehicle, so immediately they will think about that whether do we have a charging charger properly. So that is the first thing. So now the government taking lot of initiatives to increase the EV charging infrastructure, right? And second thing is that the private bodies also trying to collaborate with the new I mean with the government, and they are also going to start new venture to increase the EV charging infrastructure, right? Suppose if we completed the charging infrastructure widely, then the EV market expansion is may happen within this 5 years itself. So we do not wait for, I mean, 10 more year, right? So these are the important point to increase the EV market as soon as possible. Yes. One more thing. Is there any incentive or rebates available for purchasing and installing EV charger? See here, if you are ready to install a solar powered, solar wind, hybrid powered EV charging station, you have a huge subsidy. So that depends I mean the government of India released recently that one subsidy scheme. If you are interested, you just ping me. You can I will give you the informations. We will discuss in that. So you just take my number. If you require, you just take my number. I will give you the informations. So this is my WhatsApp number. So just a second, I will share it. 9840974408. Yes. So this is my WhatsApp number. You can chat. Yes. What are the alternative for wired charging to reduce the time required for charging? See here, how to reduce the charging time. So that is the biggest question. Again, that is a debatable point. See here, if you want to reduce your charging time, if you want to reduce your charging time as much as low, so first you should increase the prime resources rapidly. So that is the first way, right? So in the wired charging, again in the wireless charging, the again the charging may infrastructure may give you some comfort level, but as compare the wired charger, the wireless charger can will be less than that. That is the power density will be very less as much as compared to the wired one, right? Right. So now the Ola and Indian Oil and then Sun Mobility. So these three guys I mean, handshaked to increase the EV infrastructure. So this is one case study. It recently happened. The MOU signed. So for the battery swapping technologies. So here we don't have to worry about the I mean charging time. Simply just to change that battery and then you can move ahead very fast. So for the two-wheeler market, similar way, and then Volt smart swapping technology. This is also comes under that battery swapping technologies, and in association with HP. So these two guys also started one MOU to enrich the EV charging infrastructure. And in similar way, the Tata for the four wheeler, so they started again charging station into HP for the four-wheeler, four-wheeler EV. So here they have a two type of charging stations. One is that fast charging station. Some bigger stations they are going to establish with the DC fast charger. Similar way that level 2 charger also they are going to start, uh, but predominantly the level 2 charger only maximum numbers compared to the fast charger, DC fast charging. And see, actually, from our point of view, the battery swapping technology, see, actually, battery is again critical component. Simply, if you keep on changing the battery charging as well as the discharging scenario, the battery health heavily will get affected, right? So that we can understand, from the human body. See, if the temperature scenario in your human in the human body keep on changes, what will happen? So the organs of the human body will heavily affect, right? The similar way, same way, the battery scenario also. So while you keep on while you keep on changing the charging as well as the discharging scenario of the particular single battery, so the battery health heavily will get affected. So that is the second biggest challenges, right? So now, so how we can understand the EV charger, and how what are all the terminology has used, and where we have to focus to enrich the charger, EV charging technology. So for that one, first you should understand in the EV where we are using the power converters, right? So let us take the EV. So in the EV, we are going to use the power converters in the charging stations and onboard charger, then inverter drive, and finally in the EV, in the vehicle, you may have some in the EV. You may have some additional electronics, right? So for that, we have to provide some additional power supply. So all these areas, the power converters are widely used. So now let us try to understand the power converter ratings. So in the charging station, the input for the charging either may be a grid source or solar or wind energy, right? So the output is that out as per the output battery requirement. So this is the typical rating of the charging station. So 440 voltage AC, or if you take a hybrid system, then 72 or 100 volt, 110 or 3360 are the DC systems, right? Similar way for the onboard charger. So the onboard charger also has its similar ratings, like 440 voltage input, and as per the battery, that is 72 or 100 or 100 or 360 voltage DC, right? So these are the input as well as the output. And for the inverter drive, so here also the battery source as the input, and the motor terminal is the output requirement. So as per the motor requirement, we have to drive the we have to generate the voltage from with the help of rectifier, right? So similar way for the power supply, see here for the power supply, additional power supply. So either 12 voltage or 24 voltage will be the maximum one. 12 voltage or 24 voltage will be the maximum one, not more than that, right? Yeah, so let me go through your questions. Tata signed MOU with the Shell, and the MG signed with the yes, exactly. One more question. Are there any common challenges, issues in the EV charger owner face? How they can be addressed? See here, as of now, the EV charger, EV charging station owners. See here, the price is the biggest challenge for them as of now. See, for example, if you want to install a 7 kilowatt or 7 kilowatt or 15 kilowatt EV charger, so as of now, charge estimation is about 20 rupees per unit as a commercial price. And for the government, we are paying around 7 to 10 rupees as a commercial one, right? We are collecting 20 rupees and then we are paying 10 rupees. So here the 10 rupees is the margin for single unit, right? But the government, if government changes its policy, so that time, so again the biggest challenge is in the margin, right? So that is the first scenario. That is the first challenge. So that is again, it's not now, but it may happen in the future. And the second thing, the I mean, second thing is that the area for the parking the vehicle. So, if you want to charge, if you want to refill your fuel station with IC engine, I mean fossil fuels. So there you no need to worry about the, I mean what, the parking of the vehicle, right? But whereas here the parking of the vehicle in the prime locations, not at the NH or I mean or rural area, whereas in the city side, so the parking is the biggest challenges. The parking is the biggest challenges. Right. So, yes, Jitesh, I will share you the opportunities in the job, career, as well as the entrepreneurship opportunities in the end of the session. Try to engage with the entire sessions. Try to engage with the entire session. I hope you got the point of power converters, which is widely involved in the electric vehicle. Right? Do you have any more questions? If you have any questions, you just comment in the comment box. If you have any more questions, just comment in the comment box. So now, so let's discuss about the charging stations. So first one is that level one charging stations or level one converter. So usually this converter is used in the residential purpose. So for the own use, we will have this kind of converters to charge our vehicle. By default, it may go up to 2 kilowatt, not more than that, right? Similar way for the level 2 converters. So here the level 2 converter is nothing but it's a completely commercial converter. The input will be like either single phase or split phase, which means that multi I mean multi phase transformers has been used to increase the power density, right? So the maximum range up to 20 kilowatt from 3 kilowatt. And the level 3 converters. So the level 3 converters are the DC charging stations as a fast charger. So here we will use for the again the polyphase transformer system or a grid system. And see nowadays here the hydrogen I mean hydrogen powered fuel cell system also going to use in the charging stations to provide a huge range of current deliverability, right? So as of now, the level 3 charging stations are working with the grid supply, but very near future, this is going to be replaced with the hydrogen powered fuel cell system, fuel cell power system. So there you can increase the current like here approximately 400 ampere is the maximum ampere. But if you charge with the fuel cell, you can go up to 100,000 ampere. So only thing we have to increase the infrastructure for the hydrogen storage and then hydrogen conversions. So nowadays the hydrogen powered vehicles are coming up. It's lined up in the very near future. Already many countries started on this domain. Yes. So finally, that vehicle to grid and then grid to vehicle. See here, this is for not a regular purpose. It's for the small purpose to change the interact the or I mean what interchange the power from one vehicle to another vehicle. Similar way for the grid also. Similar way for the grid also. All right. And do you have any questions about the charging station types? If you have, just comment in the comment box. If you have, just comment in the comment box. I'm just waiting for your comment. If you have any comment, if you have any questions, just comment in the comment box. Yes. Dear participants, if you have any questions about the EV charging station types, can you just comment? So now we have three different type of charging stations. One is that level one, and two and three. Right. So the level one up to 2 kilowatt, and level 2 is up to 20 kilowatt from 3, and finally that up to 240 kilowatt, that is from 20 to more than 20 kilowatt to up to up to 240 kilowatt is that third level charger. So so far the grid is the prime source for the level 3, but very soon the hydrogen is going to occupy the space. Hydrogen powered power station is going to occupy that level 3 charges. In that case, we can reduce the charging time rapidly. So as of now, 20 minutes is the minimum charging time, but very soon it's going to be increased. Very soon it's going to be increased. Right. So now, so how the DC fast charger building blocks may required and typical specifications about the charging stations. Do you have any idea? Do you have any idea about the specifications of the charging stations? So ideally, the DC output should be like 450 voltage to maximum 900 voltage DC, and the switching frequency should be like a 40 kilohertz, and the power factor should be more than 0.98. So here, do you know what is the power factor? Why the power factor involved here? Anybody, can you just answer? What is the typical range of power factor? How the power factor should be? So here the 96 is the minimum efficiency of the converter. The height 96 is the minimum efficiency of the converter. So here the power factor is the key parameter to maintain the system stability in a better way, because we are going to use the power source for the nonlinear loads. Right. So the battery is the nonlinear load, because it times to time it will change the current profile, that is a charging current profile. So it's a nonlinear load. Of course, there is we are going to use uh, huge bulk size of capacitors. Of course, the capacitor will heavily affect the input power factor. Heavily will affect the input power factor. So let me check one by one. So this is the typical DC again the EV charging station or specification. Just to take a snapshot. So further we will decode in one by one. So how the block diagram can be produced? So in the onboard charger, so from the grid we will have a AC to DC rectifier or we can call it as uncontrolled rectifier. And finally, we will have a DC to DC converter. So this will enable you to yes. So this will enable you to ensure that compact design and then isolation for the safety purpose and high efficiency, right? So yes, just a second. Yes. So with the help of DC to DC converter, we can ensure the isolation for the safety purpose. Right. So again, if you decode into the detail level, so this is the typical onboard charger block diagram. Yes. So first let us have a rectifier. So the from the grid we will have an uncontrolled rectifier, and second part we will have a power factor correction because anyhow we are going to use the okay, pen not enabled. Okay, no problem. So anyhow, we are going to use the power supply to charge the battery, right? So in that case, here we will have a bulk size of resistance, sorry, capacitance and then inductance. So these two components will lead to the lower power factor. It will heavily affect the input power factor. So for that, we should provide the power factor correction circuit, right? So that's why we kept the second block as a power factor correction circuit. And the third one is that this is the high frequency DC to DC converter. So generally these two blocks will work together. Initially we will have a high frequency inverter model, and in between when the isolation transformer will be provided to provide the isolations, and finally we will convert a DC converter. Finally we will generate a DC voltage at the end of the converter. See here the entire PWM for various stages has been generated with the help of any one microcontroller. The microcontroller will keep on monitor the input current, input voltage and output current, and what is the phase difference between the current and voltage, everything the keep on the microcontroller will try to monitor, and it will take a corrective measures actions. Right. So this is the typical onboard charger block diagram. And what do you mean by power factor, input power factor corrections? See here, this is the input voltage. The first graph shows that input voltage. By default, in the inverters, I mean in the input side, the input voltage and the input current should be as like as possible. Whenever it's high, then the current also should be high. Whenever it's low, the current also should low. At that time, the phase also should be aligned. Then only we can have a high current, high power factor unity. We can ensure the unity power factor. We can ensure the unity power factor. Right? Do you have any questions? Participants, do you have any questions? Just comment in the comment box. If you have any questions, just comment in the comment box. Suppose if you are keeping the unity power factor at very less, so you should have a bulky size of conductor. And that due to this, the temperature will be the huge impact. Right? If you have a unity power factor, then you can get as much as very less conductors. Right? So how we can introduce the power factor correction circuit? See here, with the help of boost converter network. See here, this is general full bridge circuit, rectifier circuit. See here we will use one boost converter circuit. So the boost converter circuit will try to regulate the input current to follow the input voltage. To follow the input voltage, right? And so this is the typical components, how the modes of operation has been taken place. So for when you try to close the switch 1, then the circuit will try to increase the voltage because because it has the inductance, right? So when you switch off the voltage, when you switch off the MOSFET, then the stored voltage will try to dissipate with the load, right? So by keep on changing the on state and then off state, by keep on changing the on state as well as the off state, then we can increase the input current. So how it will be by default? So this is simple typical design procedure. First we should ensure the specifications. So I will show you some yes, calculations. Can you see this one? Yes, can you see this one? Yeah, so this is simple design calculator. See here, input is that 12 volt 2 kilowatt, output voltage is about 400 voltage 5 ampere, efficiency is going to work at 90 percentage, and then input voltage regulations. So here why we took it as a voltage regulation input side is the sets in the sense, if you monitor the wall socket voltage with the help of multimeter, the multimeter will oscillate either 15 percentage of 15% from the 230 voltage. So in that case, which means that what it denotes, what it trying to give you the information. The input voltage will keep on change. The input voltage will keep on change because the grid has the high fluctuations. Right? Is it clear? Participants, is it clear? Can you just comment in the comment box? Can you just comment in the comment box? Is it clear? If you have any questions, just comment in the comment box. Yes, this is simple calculator. This is simple calculator. So here, yes, sir. Thank you, Jitesh. Thank you, Dobby. Thank you, Harsh. So now we are trying to design a inductance as well as that capacitance value. So by default, this is the input. I mean what input specifications, and here this is the variations that is called what 15% from the lower side of the input, at the same time higher side of the input, and typical inductance formula. One will be percentage of ripple. The percentage of ripple nothing but that is the disturbance range. And then VAC minimum squared. So here this is the VAC minimum, and then P naught is the power, and VAC minimum again V naught is the output desired output voltage. And here the T denotes that switching frequency. So here the switching frequency is the 10 kilohertz. So by simply applying this parameter to this graph, then you can get a inductance value. Similar way for the capacitance also. Similar way, you have a capacitance also. And the R load. So just by simply I squared divided by V. So you may get a proper load voltage. So by implementing this one, yes, is there any open source simulation tool available to practice the concepts you discussed? Yes, there is a tool called MATLAB. The MATLAB will give you the perfect solutions for all the engineering problems. Right? So if you want to get a MATLAB, so just go to the YouTube, search MATLAB 2024 trial versions. You can get a video how to download and then how to install that MATLAB into your computer. You can use it. Just to take a snapshot to recalculate everything. You can design your own EV charging stations, EV charger first. Yes. So by implementing the boost converter, we can increase the input current as well as the input voltage as much as like this. But see here in this graph, if you have a current and a voltage at this like this, then you cannot get a unity power factor. You cannot get a unity power factor. All right. So this is simple MATLAB. So with the help of MATLAB, we modeled the converter, and we are getting the output voltage like this. We are getting the output voltage like this. To the main purpose of this converter is that to correct the input side voltage as well as the current in phase. All right. So if you have a if you have a unity power factor, then you can get a heating, and then harmonics are very less. So now, so what are all the opportunities in the EV industry? So the first one is that the career opportunity. So the career opportunity is nothing but if you are becoming, if you are being an electrical engineering students, then you can get a job to develop a new topology in the EV charger, motor controller, and protection devices. All right. Similar way for the firmware developer. See, if you take any electronic circuit, it has a microcontroller, right? So for the microcontroller, you should have a firmware developer. At the same time, now the EV charging infra business is entirely different thing. Whatever we are existing the rental business. So in that case, the application development for the particular EV charger and that vehicle. See, nowadays the people are telling that it's not a vehicle, it's a computer powered up with four wheel. So that is the EV. So the new definition for the EV is that computer powered up with the EV, powered up with wheel, right? And data analytics is the again one more biggest opportunity in the EV charging stations. So to match these roles, so you should have a some simulation softwares like MATLAB and microcontroller. We are running many masterclass series on these tools. If you are interested, you can get it. Yes, Satish, you can use Scilab also, but Scilab is highly limited. You don't have much facility on the Scilab. Still, you can use it. For the entry level, you can try to use that Scilab. And the PCB design also has huge opportunity in the EV designs, EV charging stations. So now you can have any, if you have any questions, you can ask me. I will try to give you the answers. And this is my WhatsApp number. If you have any doubt, just to take my number. If you have any questions, you can ask me. I will try to give you the answers. And participants, please don't forget to submit your attendance. The attendance is link pinned with the top of the chat. And if you have any questions, you can ask me. If you have any questions, you can chat. You can share me the questions. Yes. Thank you, participants. Thanks for your valuable time. And if you want to, the certificates will be shared very shortly. And to get a certificate, please submit your attendance and also your feedback about the this session, right? Yes, sir. So yes, Jitesh sir. See, actually, for the EV, how to get properly into the EV industry as a better career in the sense. First, we should acquire the skill sets. First, we should acquire the skill sets, right? So the simulation tool is any one of the tool like MATLAB or other things. Anything, any one of the simulation tool, that is the first one. Second one is that microcontroller tool. So now we are running EV design masterclass and then EV charging stations, battery management systems, all the things. So here you have I mean, what one of the uh, internship program also there. So this also will give you the detailed informations about the. Yes, I will share you the things. See here, the electric vehicle and advanced driver assistance system. So this program will help you a lot to understand, as well as that you can get an excellent career in the EV industry. So just to try to engage this session if you require, or else you can chat me. I will try to give you the solutions. So this is my WhatsApp number. You can share. Yes. Thank you, participants. Thanks for your valuable time. Thank you, sir. Thank you very much. Thanks for your valuable time.